What is up with this query and why is it slow? I've run the query against a cold cache with actual execution plans enabled. And let's take another look at that execution plan. This is the slow nested loop plan that we get after creating the non-clustered index. And I'm just gonna hover over this line that goes down to the index seek against our new index. And let's take a look at what we've got here. SQL Server is estimating that it's gonna get 6,016.2 rows back for all the babies named Matthew, but this estimate is a little bit low. Okay, it's way low. We actually have more than 1.4 million rows for Matthew. There are a lot of Matthews, but SQL Server vastly underestimated how many there were, and this carries through the plan. If I look at my key lookup over here, now if you hover over the line, it might make you think, oh, it only estimated one row. This is a little misleading on our key lookup. I'm going to click on the key lookup itself and zoom in. For this key lookup, it's important to look at the estimated number of executions and the estimated number of rows on this one. So on the key lookup, for every time it's running, it's only getting back the one row. So it did estimate I will get one row back each time, I think, but I'm gonna have to go fetch it 6,016.2 times. I actually had to execute this 1.45 million times. So it's the same estimate. It's just that this operator, we have to not just look at that bar because the bar isn't showing us all of the details for it. We can see this in the properties as well. The tooltip is just, selected properties that it's showing for this operator. Well, what's up with that? So why do we have this low estimate? Why is SQL Server, are our statistics wrong? SQL Server uses statistics, these lightweight objects that help it figure out for a given piece of information about how many rows do we have. And it seems like SQL Server doesn't know much about our Matthews. Well, let's dig into this a little bit. We can ask SQL Server, what are the statistics on a given object? I'm looking at a couple DMVs here. I'm looking at sys.stats as well as sys.dmdb stats properties, which lets us query and say, tell me a lot of info about my statistics. And I'm just looking at stats on the big table with all those rows where and essentially I want to know the stats on that one because that's the table where when the query was faster, it was doing a clustered index scan. When it was slower, it decided to use that non-clustered index. So listing out our statistics on that table, I actually have a couple of statistics for the first name ID column because I queried the table before I created an index on first name ID. And I have the default database property of auto create statistics on. So when I was querying the table, it said, oh, well, I should automatically create a column statistic for you because you're joining on first name ID. Then when I created the index, every time I create a disk-based row store index, I'm going to get statistics associated with that. So I have an index statistic on first name ID as well. Scrolling to the right and looking at this statistic, I can see the issue isn't that my statistic didn't look at all the rows. The number of rows sampled in the statistic is the same as the number of rows in the table. And it's not like data has been changing since this statistic was created. Well, SQL Server, it did use this statistic for this index when it compiled my query. Let's dig into that statistic and look at where it's getting this super low estimate. I'm going to use the command dbcc show statistics and pop in the name of the table and then the name of the statistic, which in this case is just the name of the index. It's an index-related statistic. And I can see a lot of info about this statistic, which is really cool. I love that SQL Server shows this to us. We've really got 3 parts of the information that we can see here. There's 3 data sets returned. The top here is the header of the statistic. Then we have the density vector for the statistic. And then finally, this 3rd data set down here is the histogram of the statistic. For the first column in the statistic, and in this case, that's first name ID, I actually get detailed info for the what says range high key here. I can get up to 200 steps in this histogram, and these are the first name IDs along with information on how many rows there are equal to that first name ID. Well, I happen to know that Matthew's first name ID is 28,073. So let's find in this histogram what SQL Server knows about 28,073. Now, by luck or by craft, we actually have that exact value in our histogram. You know, sometimes it can't have step for every row. We only get up to 201 steps, but we are lucky, and Matthew actually has a step in the histogram. And check this out. SQL Server knows that for Matthew's first name ID, it has 1.45 million rows. Here, let's draw in the commas just so it's really clear here. So this was not our estimate. SQL Server is not using the histogram for this. Here's where that 6,000 and change estimate is coming from. It is using this statistic. There are 2 numbers that it's using here. It is using this column in the density vector. The density for first name ID basically means for any given first name ID in the table, if I was just to pick a random first name ID, about how many rows would it have, right? Because we have some first name IDs that are going to have very few rows, and then we have some that are like Matthew and then that are going to have a lot. But like, for your sort of average, medium, mediocre first name ID, about how many do they have? That is what the density number helps us with. And to get that number, we multiply the number in the density vector times the number of rows in the table, which we can see in the header of the statistic. At the time that it last updated the statistic, here's how many rows it had. And it did actually look at every single row when it was crafting out this information. So these 2 numbers right here, and I'll show you them all on the screen at the same time to prove I have the number. Our all density number is this 3.77 E-05, right? That is our all density number. And then let's look at that header again. Here is our number of rows. When we multiply the density number times the number of rows, sure enough, we get back 6,016.2 because it rounds the number as it's shown in the execution plan. In other words, SQL Server didn't look up the first name ID for Matthew. When it was processing that join, said, okay, I don't know what the first name ID is. I'm going to use 6016.2. And what we're going to see is that SQL Server will use this estimate even for a name who has far fewer rows than Matthew. So we're going cold cache is how we're tuning this and testing this. So I'm going to just tell SQL Server, just abandon the buffer pool again. And now I'm going to run our procedure for a different first name. Show me all the phase. And I'm using this with recompile at the end of the command to say, when you execute this stored procedure, don't use the cached execution plan. That was actually Matthew's. If I don't say with recompile, I'll reuse Matthew's plan if I've run it before and not changed anything on the table, like added an index or modified a lot of data that might auto-update statistics or something like that. So we're saying give Faye a fresh plan and, don't let anyone else reuse it either. Our actual execution plans are on. And wow, Faye is super fast. When we look at Faye's execution plan, Faye got this same nested loop plan that is so slow for Matthew, but it's really fast for Faye. And the reason that it's really fast for Faye is there's only 508 rows that it has to deal with for Faye. So when it gets to the point down here of doing this key lookup, it's not doing it, 4 million times and more. It's doing it 508 times. Nested loop operators are great when you don't have to execute them 4 million times, when you're only doing it like 508 times. So this is actually a great plan for certain values of that parameter, but check out the estimate. It didn't craft this plan for Faye. It used the 6016.2 estimate. It didn't know Faye's first name ID any better than it knew Matthew's. Faye happens to be closer to an average amount of first name IDs for that table. Let's compare some estimated execution plans. This first one here is basically our exact same query that we've been looking at. It's not a stored procedure anymore. And we're not using a parameter. I have simply said, okay, I want you to use the literal value of Matthew here. So we should see our familiar plan. And I'm just gonna do Control L. Control L is the same as, let's actually highlight the right button here. Control L is the same as this icon, which is Display Estimated Execution Plan. So now I get just what would I do if I ran this query without doing it? This is our familiar plan for Matthew. If I look at the cost, this is the slow plan for Matthew. It's the same old cost. This is what the stored procedures, and cost is always an estimate, 19.75. And if I look over at the estimate here, we don't have any actuals because this is just what would you do, estimated plan, but our familiar estimate. Now let's compare this to a rewrite. I've rewritten this query so that I have specified first name ID. Now I still have my join in here, and I have even put the predicate where fn.firstnameID equals the value and this is Matthew's first name ID, but SQL Server is pretty clever. It looks at this T-SQL and it knows, hey, you're joining on these things. So if you're requiring that the first name ID over here be this integer, that also means it has to be the same value on the other side of the join because it's an inner join. This has a different plan. And I'm just going to do, once again, Control L for estimated plan. Well, that's a different shape right away. And I have a big green index hint at the top too, like where SQL Server's like, hey, you could improve on this index. You could improve on it by a lot, by 99.2%. Now, there's some problems with this. It's not suggesting I modify my index. That's a create index command, which is basically going to be a duplicate, but at least we've gotten a little smarter, right? Let's look at our cost. Our cost for this, hey, we have realized this is not a cheapo 19.2 query. This is going to be more work. And when we go over and look at the clustered index scan, and it decided not to use the non-clustered index. It decided not to use all those key lookups. Instead it said, oh, I better scan this clustered index because, hey, look at the estimated number of rows. It used the histogram this time and it said, hey, there's a lot of Matthews. For this first name ID, there's approximately, 1.45 million rows for this. And I don't want to do that many nested lookups for that. The reason that it did this, though, is because we gave it the first name ID. It might sound like SQL Server's being dumb here, but this is actually fair. And let's talk a little more back in the slides about why SQL Server didn't have this information in our stored procedure.